Welcome everyone to the next lab session of Computer Networks. Myself, Madhu Nagraj, Assistant Professor, Department of CSE Data Science. Today we will be discussing about the program 4 that is related to the error detection code using CRC CCITT. So CRC CCITT means it is Cyclic Redundancy Check Consultative Committee for International Telephony and Telegraphy, where it mainly uses the 16 bits in order to identify the error detection. So it is an error detection algorithm which was mainly standardized by CCITT, which is now known as ITU-T. So the main purpose of this algorithm was to be used in the digital networks and the storage devices in order to detect the accidental changes in the data during the transmission. So even if any one bit of code was changed, so it used the standard polynomial and it tried to detect the errors. So whenever the digital data is stored or it is interfaced, so the data corruption was an easy chance to happen. So since the beginning of the computer science, so the developers are still thinking of the ways to deal with this type of problems. So in order to overcome this problem, so they searched a mathematical mechanism, so mainly to detect the multiple false bits, or you can say some of the errors in the bits, which is called as the CRC calculations or cyclic redundancy check. So how the cyclic redundancy check happens? So first at the sender side, so what the user does is, or the sender does is, so he is going to append the n-1 number of zeros into the original data that is being sent. So then he's going to perform the modular division, and then whatever the reminder he gets, so he is going to append that many number of zeros into the data that he is sending. So the reminder, what it is there. So the reminder will be appended into the original data and it will be sent. So here, example, the word we want to send is 100,100 and the polynomial is 1101. So now the data, we are going to divide it, and this is the reminder what we get. That is, so here you can see, so there are 4 in the polynomial. So we are going to add extra 3 zeros into the data and we are going to perform the division. So once the division is done, so whatever the reminder we get, so that reminder will be added into the data. It will be appended along with the data. So here you can see the data is 100,100. 100. So into that we are going to add 001, that is the reminder. So this data will be sent to the receiver. So once the receiver receives that data, so what he is going to do is, with the same generated polynomial, he is going to perform the division. So when the division is done, so if the reminder comes as all zeros, then that means there is no error in the data that is received. If at all there is any error, or if there is any 1 in the reminder here, then that means, so if there is any reminder, then that means there is error in the code that is received. So this is how the CRC works in detecting the errors. So how the steps is done in this particular program. So first it's going to take the input data, then it is going to append the n-1 number of zeros, then it is going to perform the binary division, that is using XOR, and it is going to get the checksum or the reminder. So that checksum will be appended into the data and the final code word will be sent to the receiver. So at the receiver, he is again going to perform the division to recompute the CRC. So if the reminder is not 0, then that means error is detected. If it is 0, then that means there is no error. So let's see how it is implemented. So let's start from the main function. So always the main function is the entry point for any of the programs. So main, here we are going to enter the polynomial. So what is the polynomial? In our case, it is 1101. So we are going to enter the polynomial. Then you are going to scan it and store it in the variable t. Next, we are going to enter the generating polynomial and it is stored in the variable g. Then we are going to store the string length, that is the length of the t, into the variable a. So in the variable, we are going to store the length of t. Next. So now we are going to run the for loop. So here in the for loop, it is going to mainly check whether how many number of zeros are going to be appended into the data. So n minus 1 number of zeros are appended into the data, and it is going to print that modified data. So after appending the zeros, it is going to print that particular data, and then now it is going to call the CRC function. So the CRC function so for e is equal to 0 and less than n, that is how many number of nodes are there. So that many number of times the for loop will run. And after that, it is going to store all the values that is there in the array T into the array CS. So once the data is stored in the array CS, so now it starts from the first bit. So if at all the first bit is 1, then it is going to, so if at all the leftmost bit or the first bit it is 1, then it is going to perform the XOR operation. So what is this XOR operation? So as you all know, so in the XOR, if there are two similar variables, so that means if both the variables it is 0, 0 or 1, 1, then the output will be 0. If it is different like 1, 0 or 0, 1, then the output will be 1. So that is what the XOR function does. So we have written the same function here, void XOR. So for C is equal to 1 to n. So if CS and G, that is both are same, then the value will be 0. If it is not same, if it becomes false, then it will be 1. So that is the XOR operation that is done. So if the leftmost bit is 1, then the XOR operation will be performed. Then for C is equal to 0 to less than n minus 1, that means, so it will shift to the next position. So it will leave the leftmost and it will shift to the next position. And then it is going to bring the next bit from the T into the CS. So from T, it is going to bring it and it is going to place it in the array CS. So in order to perform the division, so it is going to shift the checksum and it is going to drop the first bit, and then it is going to bring the next bit from the T into the CS. So here it is going to drop the leftmost bit and it is going to shift, and here it is going to bring the next item from T into the CS. So this will repeat until all the bits included in n minus 1 appended zeros are processed. That is, till all the values in the main data is processed. So this loop will run and it is going to perform the XOR operation till it finds the remainder. So once the remainder is done, so it is going to come back after the CRC function. So once the CRC function is completed, it is going to print the checksum. So what is the checksum? So with the 0, whatever the remainder we get, so that is the checksum. So it is going to print the checksum. Now you have to append that checksum into the data. So here it is going to run the loop, and wherever the zeros are appended, so now it will replace that with the checksum. So here the zeros were appended. So now all the zeros are removed and it is going to append the checksum and it is going to print the final code word. Now it is going to again ask the user whether you want to test for the error detection. Like if at all there is no error at all. So if at all you want to insert the error and you want to check it again. So it is going to give an option to the user. So test the error detection. So if 0 means you want to test it, 1 means no, you don't want to test it. So here it is going to store the value. If it is 0, that means if it is S, you are going to enter the position where you want to insert the error. Then it is going to store the position and then it is going to print the erroneous data. That means again it is going to recalculate all the data, all the calculation, that is it is going to perform again the division and then it is going to store all the data. So if any error is detected, that is whenever the correction or whenever the calculation is done, so if at all E is 0 or if at all the position is 0 or if you don't get 0, then that means the error is detected. So if it is 0, then error is not detected. So wherever the position you have given, so if at all the data is flipped or if at all the data is changed, then it says error detected, else the error is not detected. So this is how the CRC program works. So this is the output. So it first asks to enter the polynomial. So we are going to enter it. Next, enter the generating polynomial. So we are going to enter. Then it is going to print the modified polynomial. So for the data, so n minus 1 number of zeros will be appended. So here we have 7. So 6 number of zeros will be appended. And after performing the XOR operation, so this is the checksum that we got. So this checksum will be added or appended into the data. So this is the complete final data that we have got. So again, here we are going to ask whether you want to detect the error. So if you say 0, then it asks for the position to detect it. So if I say 3, so at the position 3, the error, the data will be flipped. So if it is 0, so it will be made it as 1, or if it is 1, it will be made it as 0. So then after the recalculation, then the error detected will be printed. Else, if at all I don't want to detect any of the error, so if I say 1, so it says no error detected. So this is how the CRC algorithm works in order to detect the errors. Thank you.